The following audio recording has been designed for learning purposes only. Do not share, distribute, or provide any type of copies, or this audio lesson will not be made available to you. Good luck with today's lesson. Good luck with today's lesson.
Probably the simplest one to do, have a main. That main would get some values for the sides of the triangle. Is everybody with me here? So input A, input B, input C. Okay. Then you could do a couple of things at that point. Right? So one, you could have a function that you could send those values to, A, B, and C. And that function ultimately would return either a true or false, a Boolean, which on the end, in main, on the return trip in main. Right? You gotta pull that this. Let me pull that. Okay. Why don't you come?
I'll come get you. I wrote over and find some. Not if it checks it the right drive. Dude, I'm so stuck in that math exam. I'm trying to find the goddamn thing. I'm trying to find the thing. Dude. You said big chunk, right? Oh, yeah. 16. Right here. Yeah. I just bought it. Oh, that's okay. I probably did too. Studying all week, I've been cramming all these things. All I know, like, it's fucking from it.
Well, the other thing is, with all the stuff, I can, like, I've done it before, because I know how to, but I can't just remember how to do it. I literally have to look at my old work and go, oh, okay, that's what I do.
Yeah, I mean, you should.
Anyhow, so this should be a pretty simple program. Set the values to the function. The function will then in turn look at this based upon, it would go through and calculate this out given the three values. Okay, so A, B, and C. So the first thing you do in that function is you multiply A times A or A times 2, some version of that, right? Get those values and then come back and look at this guy here, okay? If these two add up on the square, right, I'm assuming these are float values on the square, to this guy squared, you have a right triangle. The problem comes into play is which one of the three is the hypotenuse. So you've literally got to check A and C, A and B, B and C, and so forth. Each one of the three possibilities to figure out which one is the longest side. Does that make sense? Any questions on that?
I wrote the wrong program.
No. It won't be the first time. So the idea is, the classic example here is 3, 4, 5. A and B, square that is 25, right? But you need to figure out which one is which. So the conditional needs to go through each one, okay? If you're going to do it absolutely correctly. My main focus in this is I want to see how you tackled the problem and the code you wrote to facilitate that. Does that make sense to everybody? It's sort of like the project. I want to know what you know, minus any crutches. Okay? So when you went to solve this, did you break the problem down, et cetera, et cetera? Okay? So the return trip here would say, if this is true, right? Squared, once you determine, right? So you could have done a conditional with at least 3 combinations. Okay, A and C, B and C, and so forth. Okay, to figure out which one is the largest side, and then execute that if this is true, return a true value on that function to determine whether this actually is the right triangle, yes or no. So back in main, the statement after, right, because you're going to call this function with like an if right kind of function with A, B, and C, and you're going to set that equal to result or something, response. Down here you say if response equals true, because I saw a few assignment statements in the conditionals, which I thought was interesting. If that's true, print. I don't care. We got one, or it's true, or whatever you'd like to have, that phrase in main. Does that make sense? That's really all I was looking for in the end. So something on that order. Okay? Now, if you're completely off in left field, that's a whole different problem. Okay? But I needed to know that you understood what this is, because this was going to require you to do these assignment statements, pass arguments, parameters, etc., etc. Because, my friends, we are going to step off the diving board now. We're going into the deep end of the pond. Okay? As of right now, right today. Does that make sense to everybody? So that's what I was looking for in the code, and I needed to see a program that supports that. Okay? Questions? Does it make sense?
Yes.
Okay. Yes, sir.
I do have one question, but completely off subject. But the project one final submission, will you submit anything on the
Yes. Yes, I wanted to see your final presentation and your final code. But I handed out grades accordingly. Right? Everybody saw the grades. And just a quick reminder, if you did not present, you know what the consequences of that is, right? I got to go back in and I'm going to wipe out all of your part 1, part 2, part 3, part 4, part 5 grades. That was stated long ago. That's part of what's going on here. So, with that, I'm going to go back down and get our colleague, and we're going to continue on. So, go to chapter 8, right? And we're going to start over here, all right, on the real world, software world version. We'll be right back.
We're on week 8. Oh, no, week 7. Chapter 8.
I don't see the world.
Any more questions about that conversation, about the term? Right? It's 25 points. It's not a big deal, but I need some sort of placeholder to give me a little bit of confidence as to where you are technically. Okay? All right. So now, my friends, we're heading into Chapter 8. Chapter 8, and what is to follow from a technical perspective is going to be the space we're going to be working in. Okay? We're going to be talking in terms of objects and all of that stuff that goes good. How many of you have had this conversation? Object stuff. Nobody? A little bit? All right, so let's talk about it in terms of sort of the real world and the software world. Okay? Maybe we can draw some parallels between the two. Okay? So, we'll forget about this guy for a while. So in the real world, and I like to use this example because any street you drive down USA will have these. Right? So if you drive down a street next to the college here someplace, you will see what on that street? What? No. You'll see
A house.
a house. Houses. Many of them. Right? That makes sense? Yes? You see a house. You know, and there are all kinds of different configurations. Right? Different styles, different kinds of brick. Some with garages, some without garages. All of that sort of look. Right? And they're typically kind of on the unique side. Right? Does that make sense? Drive down any street. Yes? Everybody has a visual model of a house. Right? So, as part of that, right, every one of those, right, has a number of attributes. Right? So, things like number of bedrooms, maybe number of baths, style. You know, is it a colonial? Is it a ranch? Is it a tri-level? Is it a quad level, etc.? A split level? What else?
Stairs.
I'm sorry?
Stairs.
Okay, could have stairs.
Some have garages, some don't.
Garages,
Basements.
right? Garages, basements.
Pool in the backyard.
Well, that's not something that would typically be part of the original construction, right? So, what dictates this? You know, so you're in the real world. How do they just grab a bunch of raw materials like lumber and pipe and electrical wire and stuff like that, and just throw this thing up? What do they use? Use something like a road map of some kind to construct this thing?
Blueprints.
A blueprint. Okay, a blueprint. Does everybody follow what I'm talking about here, right? So this is a document that when you look at the document, right, for example, looking down on that document, it'll tell you, for example, how many bedrooms perhaps and how many bathrooms and all of these kind of things, right? That sort of dictates the structure. Is everybody with me here?
Mm-hmm.
Does that make sense? Any questions about that? And the guys that do this, the folks that do this kind of work, I'm sorry for using the guys thing, but the folks that do this type of work would be people like carpenters, a couple kinds of carpenters, like there's a finish carpenter and a rough carpenter, right? Plumbers.
Electricians.
Yeah, electricians. So you're
Safety
getting it.
inspectors.
What's that?
Safety inspectors to make sure that everything's working the right way.
I suppose, right? But electricians, cement guys, right? Cement / bricks. Yeah, the junk phone calls are crazy. Anyway, so these would be sort of the folks that do the work. Do you agree?
Mm-hmm.
They look at that blueprint and they say, oh, I need to do this. I need wiring from here and sockets. I need to run some plumbing. I need to stack the bricks in a certain way, etc., etc. Are we all sort of in tune as to what's happening? So These would be, for example, some of the attributes, perhaps not all of them, but some of them, right? And these would be the folks that sort of do the labor, do the work. Yes?
Correct.
They also probably have a general contractor. What is this person or group of people's responsibility?
Isn't their job to find everybody?
Managing all of this stuff, right? They're managing the overall picture, right? They're like the building, okay? Are we all still with this in the real world kind of thing?
Yeah.
So, attributes. The worker types, right? So this is the real world. And you can look down any street, USA, for that matter, any street globally, right? You might have little different kinds of structures, but they would have this kind of a house thing, right? Some sort of, even if it was a group of apartments, right? But they would have attributes like this. They'd be built according to some kind of a blueprint, and they would have this workers that would do these kinds of tasks, right? We're all in agreement here? So now, let's go from the real world, let's go over to the software world. Okay? How do we build a house, for example, in the software world? Any ideas?
You dig a freaking pit.
In software?
Yeah.
You may
lay
end
a
up,
foundation.
we will lay the foundation. Okay. So over here, right? We don't use a blueprint. We use something called a class definition. Okay? Class definition. That's our blueprint. It's what dictates what we're going to build. Okay? These attributes here, we can have direct, exactly similar attributes. Okay? In the software world, right, these attributes have a slightly different name. They're called members of the class. Okay? So, over here, if you wanted to represent the number of bedrooms, what kind of a data type item would you want to use? An integer, right? Does that make sense? Although, I suppose you could use a float. Is there such thing as a half bedroom? I don't know. But let's just say integer. How about number of baths?
That one you can use a float.
I would say that probably needs a float because you can get like a half bath or something, right? I don't know if you can get a third bath, but at least a half bath. Right? So, float. How about style? Some sort of a string, right? So it would be like colonial, ranch, tri-level, right? So it'd be some sort of a string. Okay. Stairs. What would you have for stairs?
Would you have like an integer for each step? Or?
To begin with, I would probably just say, does it have stairs, right? Because certain styles of houses would have stairs and others wouldn't.
Maybe like a callable function, something.
I'd probably go more with something like a Boolean, right? Boolean would say, do you have stairs, yes or no? And that could be dictated by this. Right? So if you have a colonial, you have a second story, you're going to have stairs. Now, you may have stairs also if you have a basement, right? Boolean, yes or no, do you have a basement? And if so, you're probably going to have stairs or not, right? Does that make sense?
Mm-hmm.
To represent those kind of attributes. All right? Same thing with the garage, right? Again, this would to be determined, right? Do you have a 2-car garage, 2.5-car garage, or you don't have a garage, right? Those are sort of the things you would see if you looked at Any House USA. So I would say, to begin with, at least a Boolean that says you do have, yes or no, a garage.
What if
detached. Well, that could be some sort of an attribute that you could add. Remember, this is not the complete list.
Right. Well, I'm saying, like, if it was, let's say it was attached.
Could you, yes. Yeah, I mean,
Never-
obviously you could put a conditional in here that says, is it an attached or detached garage, yes or no, right? So you could do some sort of secondary thing here if you'd like, right? Keep that idea in mind because we're going to come back to that. Yes, sir.
What is the equivalent of a blueprint again? For
Class.
And so the object. Okay.
We're coming. Okay? So we've got this part of it covered. Do we agree?
Yep.
On the software side. Here's our blueprint. Here's our attributes. Here's where it gets interesting. Guess what? We also have these. We have the workers, the laborers that build the structure for us. Does that make sense? On this side, right, so over here, attributes are members. That's the classic OO term for them. And the term over here for these workers are called methods. Okay? And sort of the unique part about this is that every time you create an instance or you create a house, right, not only do you get the members, the attributes, but you also get a set of methods, a set of functions, specifically to be used by instances of that class. An instance is an object of the house. Right? Does that make sense? We're going to look at it in much more detail, right? But I'm trying to draw some analogies between this side of the world and that side of the world. Okay? So we have workers. We even have a general contractor. He's got a really special name. His name is called constructor. Okay? Does that make sense? We're going to come back and we're going to look at this in the software space. Okay? And then we're going to go back and look at what's in Chapter 8. But I needed everybody to kind of get to this page. This is sort of the initial leap that you need to make. Does that make sense? Questions? Do you have sort of a rough flavor of what's happening here? So here's the real world, and here's the software world version. Questions? I'm sure there's a million of them brewing around, right? But we're going to come back now. We're going to go look at what this might look like. Yes, sir?
You said, so if the object in the real world is a general contractor?
Well, no. The general contractor is the overall person responsible for building this, right? He's the builder.
Okay.
His label is called general contractor. On this side, we have the same guy, and believe it or not, his name is a constructor. Okay? His name is the constructor. And we're talking in terms, remember, the concepts we're discussing here are the classic object-oriented concepts, regardless of language. So, learn it now, learn it later. My friends, you will learn it if you want to be in this business. This is the only language in the real world. I mean, in real world for software development. We talk in terms of objects. So let me take one more step into really deep water now. So you currently have a straw. I'm about to add 3 levels to the straw with this next statement. Every time you create an instance of the object, you create a house in software, you get all of these currently, right? These are the ones we have listed. There's obviously many, many more. And you get all of these. So, in the past world, in our previous life, right, we had the simple data types. We had ints and floats and strings and lists and tuples and so forth. Okay? Now, those are nothing more than simple elements inside of this class. Does that make sense? We've got ints and floats and blah, blah, blah. We can have arrays in here. We can have lists. and tuples all part of that overall structure. So in the past, when I said int I, and I said what is the data type of I, the answer was integer, right? When I said int I, we defined something as integer, right? Now, when I ask you what is the type of this, what is that answer?
Class.
No.
Object.
It's of the type house. It's of the type house. Like I said, here's a few more straws for you. All right? So when we create an instance of the house, okay, it is of the type house. And that type contains all of this and all of this. Not just int I, or list so-and-so, or dictionary, whatever. Okay? You get the entire thing in one shot. Okay? Is everybody kind of following along? So we are now into what's called abstract data types, truly abstract data types. They're self-manufactured. They're, when you talk to somebody who's in the art world, does anybody know what an abstract painter would be?
Somebody who can't think.
Picasso.
Okay, well, he said somebody who can't paint. Let's be a little nicer here. What's an abstract painter?
Someone who paints the world in a different way from the conventional.
Okay, but I think it's a little, that's sort of maybe the media version of abstract.
I'm taking a few art classes.
It's probably more on the order of, it's that artist's perception of something. Does that make sense? Mm-hmm. This is the way that artist sees it. Okay, like Picasso was a great abstract painter, but he had his own sort of unique way of portraying it from his perspective.
Especially with his painting Guernica.
Well, look, let's not go there.
I like that.
So, do the data types that we're using so far exist? Is there one large class?
No. Nope. Classes are completely now, like I said, we're out of the simple world. I hope you enjoyed it because we're leaving. We're going on. We're sort of saying, okay, we did math, addition, subtraction, multiplication, and division. My friends, now we're going into calculus. You needed that foundation to get you there. Okay, because those simple data types are what's in here. They're the members in the class. Okay?
So, all the data types for house is simply of the type of
House.
Of the type of
House.
Of the type house.
Yeah, when we create an instance of house,
Right. And so, of the type house itself is a class.
is the class definition. Okay? Let's take a look at what this means now. Okay? It always helps to sort of have a little foundation, right? And this is one of my problems with the textbook we use, because it doesn't discuss this. That's why we went the path we just came to get to here. That's great. I need a little jackhammer action here. All right, so let's go take a look at what this looks like now. Okay? It's kind of fun. It's a little exciting. And again, this is all in sort of support of our little field trip. Okay? Did we talk about the field trip yet?
You just mentioned it.
Yeah, we're going to go on a very short field trip. We're not leaving the room, but we're going to go on a short field trip, and we're going to work on a blackjack game, creating a card game. Okay. So let's go out and let's open up some Python here and see what this might look like. Like I said, it's all entertaining.
So,
Go ahead.
okay. So with the object house, inside of the object house, It's kind of like it's an abstract data type called house, right?
Yeah, it's
And-
a data. Let's put it this way: it's a data type that we created. It's not an int or float or this.
That's sort of what I asked earlier.
And in the class house is going to be all of its
Attributes.
integers, its floats, its
Yeah,
booleans,
all of the
whatnot.
attributes.
And the layout is going to be kind of like another class that, or I guess the workers are like, they could be a different class that like
Well, let me explain something.
get output out of all
These
the data.
guys, we used to call them functions.
Okay.
We used to call them functions. Now they're called methods.
Okay.
Okay. This is there's nothing really new here, short of the fact that we're going to glue all of these pieces together into this big homogeneous thing now, right? Not only are you going to get the data, but you're going to get the functions to manipulate that data. Does that make sense? And they're specific to an object or an instance of house, right? So I'm throwing around a couple terms here, right? So I'm attributes are members. Functions are methods. Instance/object are interchangeable. We've created a class, an instance of the definition or the class. This guy here, this blueprint for house. All right. So let's go do that. Let's go do that. Come on, let's have some fun. Everybody into the pool. Going out and opening up Python. Like I said, here's the other part of the message. In order to take advantage of Pygames, to use Pygames, and for that matter, pretty much all other game engines, it's all object-based. It's all classes. Okay? So to be able to use that, you have to understand this. Okay? So we're going there. We are going there. So let's set this up. Here's our shell. I'm going to get a new window. Right. So let's follow the standard protocol. You know how all that stuff works. PF main. Right. We're going to go down here and call main. And now, let's get to our class. Let's get to it. So I'm going to create a class called house type. And might have to make some changes, some improvements. Right? So we're going to start out real simply. And anything that's underscore like that, right? These are system-specific standard naming conventions. Okay, and we're going to see several of these. This one here, the underscore ANIT underscore is the constructor. This is the constructor. So when we say I need to make an instance or an object of house type, we're calling this guy. This is our function. What do we call him now?
Constructor.
No, it's a constructor, but we call it a method. It's a method. Okay? So, let's make it real simple first, just so we kind of get our boots on the ground. Okay. Ready? Here we go. House equals house type. Then, let's see what happens. So, my friends, just like at the beginning of the course, let's see if we can create an instance. Let's see if we have some problems. So when I execute this line of code, what this is saying I'm going to create the object or the instance called house, and I'm going to use the class name house type, which in turn will call our constructor. And what should we see if this is good?
Say, hi, I'm alive.
Hi, I'm alive. And we will have created our first instance of house. Our first instance of house type. Right? Our class name is house type. Let's see where I am. Desktop. Ready? We have a problem, my friends. We have a problem. And this is there's going to be several sort of tricky points here. Okay? So the next sort of piece we need to get our arms around is the idea that every object or every instance in this particular case of house type that we create is unique. So if I want to know about a specific instance, a specific house, I have to use what's called self. Okay, self means I want to talk to that particular one. Okay? Here's where it gets a little odd. So I need to put an argument in here that says self. It really, okay, here's the thing. It really is not a parameter. It's simply there that says, who am I talking to? I'm talking about this object, this particular one. Okay? So let's see if this helps. Let's see if this is my problem. Looky, looky. So we've created our first instance of house type. Called it house. Does it have any attributes or arguments in it? No attributes, no members yet. Okay? But we're able to do it. So if I wanted to, think about this, if I wanted to create 5 instances of house type, in other words, I'm populating 5 houses, building 5 houses on a street, right? All I need to do is that, and I'm going to make it even easier for us to identify them. 3, 4, 5. So when I execute this code, we should see hi, I'm alive 5 times. So we've created 5 instances of the house type class, 5 house type objects. And they're known as house 1, house 2, house 3, house 4, house 5. Okay? Is everybody with me here? So if you were to think about this in the bigger picture scheme, right, you would have something that looks like this. 1, 2, 3, 4, and 5. Each of which right now has no attributes. And it only has one method. What's that method called? The constructor. Okay? So they each have this. I'm going to make these diamonds, right, sort of following the OO conventions, right? All right, and this is the underscore INIT in each case. Does that make sense to everybody? Mm-hmm. Each one of those has the same thing. So, pat yourself on the back. You've now created 5 objects of house type. Each one is called house 1, house 2, house 3, house 4, house 5. If you wanted to know anything about a particular instance, a particular house, right, you would have to use the instance name. So house 1 or house 2 or house 3 or whatever. We're going to come back and look at that. But I want you to sort of think about this, right? So each one of these guys, house 1, house 2, house 3, house 4, and house 5. Those are the instances or the 5 house type objects we built. Is everybody with me? Okay. Everybody good? All right. Let's start adding to our class definition to our blueprint. What?
Does it have to be given the argument of self?
That is a requirement, okay? And you'll see why that's the case shortly. Self is very important, as I said. In this case, who's self?
The general contract.
No, who's self? House 1. In this case, self is house 2, house 3, house 4, house 5. They're absolutely independent things. Okay, everybody rolling along here a little bit. So let's go out and let's add some attributes. Okay, so I'm going to come in here and I'm going to add one of the attributes. So let's put in a num of bedrooms. Okay, no problem. Right, MBR. Okay, and I'm going to say, and just for conversation, NBR equals input. And actually, it's int of input. Why am I doing this? Huh?
At the same time?
Well, yeah, but how does it come in from the keyboard?
Oh, it's a string and then you're turning it to a...
Because we want it to become ultimately, what's it say right here? Integer, right? So, how many bedrooms are in this house? Right? Then we're going to send that in. But in order to get it to be part of the actual instance, we actually have to set some values up. So I'm going to add NBR, right? Because remember, who are we calling when we create our house 1 instance?
House 1.
No, who are we calling? What am I calling when I do this? No.
The constructor?
The constructor. This guy here. So if I want to get this into that structure, and for that matter, all of the other structures, I got to add it in. Right? So, let's put in NBR. Okay, NBR. And then I'm going to say, ready? Self dot num of bedrooms equals NBR. Now I've got that there. Okay, I've brought that. I have my member, and it's being set as part of the constructor. Remember, the constructor is the guy that builds the framework, that's responsible for getting everything in the place where it's supposed to be. Right? He's following the class definition. Does that make sense? So far? All right. So while we're in here doing this, I'll leave this hi, I'm alive, but typically you want to know that what the status of your instances are. What are the values of our attributes, our members? What's the status? What is in those items? So, time to introduce another method, standardized one. str underscore underscore, right? And I'll add the self, right? And I'm going to do a couple things. I'm going to say rep equals house instance attribute, or I'm going to call them house instance member values. Okay? And I'm going to put a \n on this. \n, does anybody know what a \n does for you? Carriage return line fee, right? Takes you to the next line. And then I'm going to say REP equals REP plus self dot num of bedrooms, and I'm going to do an str on that guy. Why is that? What am I doing? Yes. So I'm going to do that. Then I'm going to add the quote \n again to this guy, right? And you ready? I'm going to do a return REP. And down here, I'm going to do something shocking. Ready? Print house 1. So let's see. Do I have everything in there I need? Maybe not, but we'll find out shortly. So now, right, remember what we're doing. We're checking the status of the members for an instance of the class. So another standardized method, and it's actually not a method, it's a style, right, is the __str__. Okay? This is a method that will give you the status of the members at this time, right now. So I'm creating my instance. I'm sending in this value. This guy here calls the constructor. It sends in the value. Remember, self does not count. It's saying I'm talking about this instance. What's our current instance name, object name? What is self here?
The house, right? Each house?
House 1. House 1, right? This is self. So when I get to this line here, so I'm setting the values, and when I do this, it's actually calling this guy here. And that guy is telling me, here are the values for the members for this particular instance. Okay? Again, this is going to take some time, my friends, to get used to. But this is a very powerful paradigm in the overall picture of what's going on. So let's see how bad off I am. And if it's a problem, so I'm going to say 3 bedrooms, hit enter. It shows my 3 bedrooms, right? Correct? No problem. Where is it bombing now? It's bombing on house type 2. And what's the error? It needs what? It needs me to add the NBR value. Right now, NBR is equal to 3. So it says, house instance member values are 3. So we should probably do a little bit more work here so we know which member we're talking about, which attribute we're talking about. So I'm going to put the string on here that says of bedrooms. So now I'll have that identifier. Let's run it again. So this value of 3 won't be sitting in the middle of nowhere without any idea of what it is. Right? What is that member or attribute? So I'm going to do it again. I'm going to say 3 and number of bedrooms for this particular house instance. Okay? You with me here? So this guy calls the str method. I've got it defined as such. Now we're getting an error on this line. Why is that? Because we're not sending it the NBR. The constructor says, hey, I can't execute because I don't have a value for NBR. We don't have this in there. Does that make sense? So let's do that. Let's add NBR to all of these. And to sort of clear your mind, I'm going to do this. For each one of these. So that's for 2, here's for 3, here's for 4, and here's for 5. And I'm going to call, I want to see what the values are for each one of my new instances. So there's 2. So instead of house 1, we're going to print 2. What is the status of house 2? So let's, after this one, let's do it there. And so this is going to be 3. I'm going to clean this up in a second. And then this is 5. This should be house 4. Here's this guy here. This should be house 3. So let's break this up a little bit so we see a little clearer as to what's happening. So there's 1, 2, 3. This guy, up 1. Put him in here. Drop this guy down. So we're going to ask for each one of our instances the number of bedrooms. Right? So the first one I said 3. This could be 2. This could be whatever. And we will, my friends, be able to see what the attribute values are for each one of these guys over here now. Right? House, remember, self in each case represents these separate instances. So let's run this code. Okay, how many bedrooms for the first one? 3. How many bedrooms for house 2? 2. House 3? 5. House 4? 4. And house 5? 1. There you have it. The attributes have been set. So we have 2 methods now over here. We have the constructor, underscore init, underscore, and we have the underscore str, the status method, for each one of these objects. Right? Is everybody following along? And we have a single attribute, which is num of bedrooms, in each one of these. Right? Each one of them. One attribute and 2 methods.
Now, in the principle, can we like identify each house by the streets and brick house?
Well, okay, let's put it this way. Here's what I want you to do. I want you to go back into the code now. And I want you to take, let's do the simple one. Let's do style. I want you to add that attribute. And I want you to add that to the status method. So we'll see number of bedrooms and the style. We'll be you execute the code. So make the code mods to make that happen now. Shouldn't be terribly hard to do, right? You have the model in front of you for house 1. Isn't this fun? We've just left the planet. Able to modify the code to solve the problem. You ready to go? About 3-4 more minutes.
Mr. Slice, could you repeat what you want us to do again real quick?
So I want you to add the style member
Okay.
to our class definition, get the information from the user, and display the status of each one of our classes, each one of our instances. Okay? Should take about 5 changes, maybe 6. Maybe this one. This is fun stuff, guys. No. Everybody got it done? Good. What's that? All right. About another minute. Ready? Here we go. So we have to do a couple things. So you got to modify that blueprint to take into account, right, what's happening. So that means I got to go into the constructor, and I'm going to put in ST, and I'm going to get this guy. Style. And set the value as ST. And I'm going to modify this guy here so that when I ask to see what the values are of the status, right? So I'm going to take here and I'm going to say style equals self.style. What is self.style? What is style in this particular case?
Style code.
Right, but what is it in terms of the class? What are these called? No, methods are the functions.
Remember?
It's a member. It's a member. It's an attribute. Right? So once we got that done, so I'm going to leave this guy alone, but I'm going to use him as a model. And I'm going to say, instead of this, I'm going to say STYL. STY, what is the style of this house? Of this house. Okay. And then I need to take STY, drop it in there. And everything should work, so I need to do this.
So you didn't have to do rep equals rep plus style?
I did it right here. Right?
Right, so for example, like you have rep equals the house instance number value, and then you have rep equals rep plus, and then for the third one you ain't have to do rep equals rep plus.
What third one? What do you mean? It's there. This is house 3. House 3 is there. And house 4. Right. And house 5.
Don't you have to make STY a string instead of a string?
Ah, you are correct. So I don't need this. Right? Because it's coming in as a string. Right? So I don't need to do the conversion here. Here, or here, here, or here. Or here. And I actually don't even need to do it here. Right? Because style should be a string coming in. Ready? Let's see how we did. How many bedrooms? So I'm going to say 3. Style is ranch. Looks like my stuff is showing up. Second one is 2. Colonial. It's awfully small. Colonial. 2, 5. Tri-level. 5, 4. Split. Level ranch. And 5 should be 1. We're going to call it mailbox. Okay? There you have it, my friends. We've just expanded it so we have our attributes in place, right, for each one of our objects. Again, we've now added an additional attribute right here, and it's called style. Each one of the instances now contains style.
There was a way to write our games using object-oriented programming, wasn't there? I mean, if they had enough like functions going on.
Oh, there's always a better way. There's always a better mousetrap. Right? We weren't ready for this yet to make the deadlines.
Yeah. But I mean, at a certain point, passing around from function to function is like becomes more complicated than this could ever be. You know,
You have yet to see where this goes.
Okay.
All we're doing is creating what is that instance look like.
Right.
We're not talking about collision. We're not shooting anything. We're not moving. We're not doing anything.
Text adventure game, you know?
Oh yeah, you could use this.
This would have made things a little less complicated.
So let's on that topic. Okay, on that topic. Think about this. You have a class called enemy, right? The enemy has its attributes. It has its methods, right? I want to create a wave of 500 enemies. What would I have to do? Create 500 objects, put it in the loop, and boom, you're done. Here's your 500 objects. Right? Now remember, we're doing this sort of the hard way. Not the hard way, but the simple way so everybody kind of understands what's happening here. Right? Again, all we're doing is creating instances and displaying the value of the attributes. Does it make sense? We don't have any of the other methods, right? So we're going to start, as this continues on, right, we're going to start adding methods for movement, adding methods for collision, all of that kind of stuff. Those are all going to be methods in support in the class. I mean, we're not there yet. We're probably 2 weeks, maybe 3 weeks away from doing that. Okay? Like I said, we got to go on a field trip here. We got to learn about the garage classes first. Okay? So what I'd like you to do to think about between now and Thursday is how would you now turn around and modify our class definition to have all of these attributes in it? What would you have to change? Does that make sense? Don't forget, we've got some specialized things coming yet. Right now, all we're doing, and this isn't an assignment yet, but I want you to think about how you would do that. If you want to play around with this code, be my guest. Right? Create the object. It has maybe 7 attributes and only has a constructor and a status method. Okay? Does that make sense? Think about what you'd have to do that. Okay, what would that code look like? So when we come back on Thursday, right, we're going to talk about this. We're going to pick up from here, and we're going to add maybe 1 or 2 more attributes, and we're going to move into the next thing that we need to add to this now. Okay? Questions? Welcome to the next section of the course. It's all OO. Still vanilla Python, though. Okay, we're not getting into anything else quite yet, but it's coming. All right? If you have questions, stick around. Other than that, we'll see you on Thursday.
So many possibilities.
Yes, sir.
I don't know why it's giving me an invalid syntax right on my right on my rep thing, but I thought I copied it exactly how you said.
You might have
Just on a quote. I also keep on getting it on house 4 for whatever reason.
Do you
Plus
still have
style, rep plus style. You got a concatenate rep with that string of styles. Just put plus style.
So for that question is why I needed to. I originally had him as K. I switched.
I did
it.
everything you did while you had the time to figure it out. The only difference I made was I had
You
rep
need to have
plus rep
STY
right
as
here.
an argument.
Rep, but rep
in it.
plus.
Where do you
Right.
You see,
So I
you
did
got
rep
like-
equals
so you got
rep plus
everything
rep.
stuff. So change
2
this
reps
to
are
STY.
only going to take whatever this is
Right.
and multiply it close.
Okay. Alright.
No,
So it
it's
didn't really
not.
make a difference.
That's STY.
Shouldn't.
Okay.
Other than you
Add
add extra
STY
stuff.
as
Right.
put a comma.
Now-
No.
Back to the original question.
Go inside your argument.
Thank you. 15 quiz. Oh, that's okay. Okay, thanks.